Hello children, I am Rizwan. Today we are going to learn about symmetry. Children, ever noticed that some things are symmetric? For example, the letters H, A and M all look the same left and right. The letters B, C and D are the same along a horizontal line. The letter X is symmetric both horizontally and vertically. A perfectly round O shows symmetry around its center. Symmetry plays a central role in the analysis of the structure, bonding and spectroscopy of molecules. For two objects to be symmetrical, they must be of the same size and shape, with one object having a different orientation from the first. Let's study more about the topic below. Learning objectives. After the completion of this lesson, you will be able to understand symmetry, to understand the different types of symmetry. Keywords from this lesson are symmetry, line, shapes, divide, vertical, horizontal, rotation, reflection, image. Children, now let us see different types of symmetry. Line of symmetry. Have you ever thought about how an artist makes a masterpiece through his artistry? Everything made by an artist is in perfect line of symmetry. From sculptures to portraits, an artist does wonders with his hands. But did you know that every creation of an artist is a balance of maths? Yes, the maths of symmetry harmonizes shapes and patterns. Let's see how. From the most beautiful architecture in the world, Taj Mahal, to the modern skyscraping edifice, one thing common to these is the flawless symmetry of the structure. Symmetry is a very common word, but do you know how symmetry works? What effect it has, or why we need to put things in symmetry? The answer seems simple: to give perfection to our creations. But is it that easy to bring creations under the line of symmetry? The answer becomes a yes when we know how the concept of symmetry works. Symmetry finds its origin in the Greek word which means to measure together. The concept of symmetry finds great usage while studying geometry. Mathematically, symmetry implies a shape which is an exact resemblance to its other part, when the shapes are divided into two or more equal parts. Such shapes or figures or images are called symmetrical. The ones that do not resemble each other when divided into two parts are called asymmetric. If in a shape or image you draw a line down the center and notice that the left side is a reflection of the right side, then the image or shape is said to be symmetry. For example, take your face. When we draw a line, down our face exactly at the center, then the left side of our face is symmetric to the right side of the face. This defines symmetry. The line that divides a figure or shape or any image in identical halves, then that figure is said to have a line symmetry. The line that divides a figure into identical halves is called the line of symmetry or the axis of symmetry. The line of symmetry is also called a mirror line because it produces two reflections of an image that coincide. Children, let us see the types of lines of symmetry. Lines of symmetry may be of two types. Vertical line of symmetry. A vertical line of symmetry is that line which runs down an image, thus dividing it into two identical halves. In other words, it is a straight standing line that divides an image or shape into two identical halves. Some English alphabets also show symmetry when divided into halves. A, H, M, O, W, U, Y and X, etc. are some alphabets that can be divided into equal halves by a vertical line of symmetry. Horizontal line of symmetry. A horizontal line of symmetry is that line that runs across the image, thus dividing it into two identical halves. This line may also be called a sleeping straight line that parts an image or shape into identical halves. The English alphabets also are a good example of horizontal symmetry. Alphabets like C, E, H, K, O, X, etc. can be divided into equal halves by a horizontal line of symmetry. Rotational symmetry. When you rotate a star-shaped figure, what do you notice? The shape of a star, when seen from any angle, seems the same. Have you ever given thought to the reason behind this? A star is an example of rotational symmetry. It is not necessary that an object must always have a line of symmetry to prove its symmetrical attribute. There may be some objects which show symmetry despite the absence of the line of symmetry. Such symmetrical objects show rotational symmetry. Rotation means the circular movement of an object around a fixed axis. A clock is the most common and regular cited example of rotation. The needles of the clock move around a fixed point to tell us time. The movement followed by them is called clockwise rotation. If any object follows rotation in a direction opposite to the clock's movement, then such rotation is termed anti-clockwise. Other common examples of rotation are the blades of the ceiling fan and the wheels of a bicycle. This is where rotational symmetry finds its origin. Also known as radial symmetry, rotational symmetry is that characteristic in which the object looks the same despite its rotation of it. When an object rotates around a fixed axis, if its appearance of size and shape does not change, then the object is supposed to be rotationally symmetrical. The recycling icon is also an example of rotational symmetry. Have you ever noticed something peculiar about the recycling icon? You look at it from any direction or orientation, the shape is unchanged. This is what rotational symmetry does to the figure. In rotational symmetry, despite the circular movement, the shape and size of the object or the figure looks the same. In the recycling icon, the arrows of the icon appear to be circularly moving, which suggests the rotationally concept of the recycling. When this icon is rotated to any angle, after every halt, it shall look the same. Attributes of rotational symmetry. Now, let's consider a paper windmill to understand the attributes of rotational symmetry in a better way. A paper windmill is the most joyous toy for every child. Its rotational movement amazes every child, but its unchanged appearance despite continuous rotation adds to the whole amazement. A paper windmill is a perfect example of symmetry. Now, you may be wondering that in a paper windmill there is no line of symmetry and nor can it be folded. Then, what kind of symmetry does it show? The paper windmill shows rotational symmetry. It is fixed to a stick by a pin. This pin is its center of rotation as its blades rotate around the pin. When we forcefully rotate it to an angle of 90 degrees, then we see despite the movement there is no change in its appearance. On the further movement, the shape of the paper windmill is same as the original. The figure below illustrates this more accurately. The angle at which this paper mill is turned is called the angle of rotation. Here, the angle of turn is 90 degrees. A full turn of rotation measures 360 degrees. So, for taking one full turn, our paper mill is moved 4 times. Do you notice any change after a full turn? The answer shall be a no. The reason for this is that the paper windmill shows rotational symmetry. The number of turns given to an object to come back into its original position gives the order of rotational symmetry for that object. In the case of the paper windmill, the rotational symmetry is of order 4. Reflection. When we speak of reflection, the first thing that strikes our mind is a mirror. A reflection is an image that is an exact copy of its original, formed in the mirror. Now, when we see perfectly symmetrical figures, we can easily conclude that both parts are a perfect reflection of each other. Reflection and symmetrical figures. Have you ever noticed why the mirror image of ambulance is written on the medical emergency vehicle, ambulance? The reason for doing so is that the reflection of the word ambulance is seen in the rear view mirror of a vehicle ahead, which helps the driver know that an ambulance is behind them. Seeing yourself in the mirror is the most common thing that we do in a day. In fact, our day starts with looking in the mirror. When you see yourself in the mirror, you can see an identical person of the same size and shape and face in the mirror. Now, what you see in the mirror reflects yourself and is called the mirror image or reflection image. An object and its mirror image are perfectly identical to each other. The left and right sides of an object appear inverted in the mirror. This object and its reflections image show mirror symmetry. The mirror line here is the line of symmetry. So, when we see an image of an object in the mirror, then the object is symmetrical with its mirror image. This view is similar to folded paper. When a paper is folded exactly in the middle, the line of the fold is the line of symmetry. This line of the fold is like the mirror line. The image formed in the mirror reflects the object in the line of symmetry. Reflection of alphabets and figures. Now, let's take the case of a figure or shape or an alphabet. When an alphabet is seen in the mirror, we see its exactly inverted reflection. Only alphabets A, H, I, M, O, T, U, V, W, X and Y are identical reflections of the real image. When a figure is reflected about the mirror line, then the reflection image is congruent to the real image. This means that the lens and angles of the mirror image are identical to the lens and angles of the real image. The image, however, is a lateral inversion of the real figure. So, in a nutshell, the reflectional symmetry for symmetrical figures is also referred to as bilateral or mirror symmetry. This occurs when the mirror line works as a line of symmetry that divides a shape into identical halves. Here, each half is a perfect reflection of the other part. There are some shapes or objects like circles, squares, and triangles that have more than one line of symmetry. These shapes or objects, when seen in a mirror, are not lateral inversions of each other, but rather are identical reflections. Summary of the lesson. Symmetry finds its origin in the Greek word which means to measure together. The line that divides a figure into identical halves is called the line of symmetry or the axis of symmetry. In rotational symmetry, despite the circular movement, the shape and size of the object or the figure look the same. An object and its mirror image are perfectly identical to each other. The left and right sides of an object appear inverted in the mirror. This object and its reflection image show mirror symmetry. The mirror line here is the line of symmetry. Thanks for watching.